Okay, today we're going to look at something we looked at the last time we talked about gases. Last time we talked about gases, one of the things we found was that from the density we could find the molar mass, and from the molar mass we could find the density as long as it was at STP. Today we're going to talk about what do you do if it's not at STP. So, molar mass. Molar mass is how many grams for each mole. So that's grams per mole. So to find that, you take the grams and divide it by the moles. So in order to figure out the molar mass, I need mass in moles. If they give me the mass and PV and T, from pressure, volume, and temperature, you can find moles. Then you can take the mass and divide it by the moles. So we're just going to do a Pivner problem and solve for n, and then take that number of moles and change that to molar mass by dividing grams by those moles. So here's an example. It's number 16 on your example sheet. So let's give this a try. So what is the molar mass? They want molar mass, and they gave me 0.427 grams. That's a mass. 0.98 atmospheres, that's a pressure. 20 degrees Celsius, that's a temperature. And 125 milliliters, that's a volume. So from PV and T, I can find N, because PV equals nRT. Oops, sorry about that. nRT, so to find N, I have to divide both sides by R and T. So I get N equals PV over RT. The pressure was 0.980 atmospheres. The volume, they've got us 125 milliliters. I can't work in milliliters. I got to change that to liters. So if you remember, you can move the decimal point 1, 2, 3 to the left, and you get 0.125 liters. The reason why I have to change it into liters is because R has liters in it. So I need to match the units for R. And I divide that by R. And since we're in atmospheres, I use the one with atmospheres, which is 0.0821 liter atmosphere over moles in Kelvin. And the temperature, 20 degrees Celsius, is 293 Kelvin. So pushing the buttons on my calculator, 0.98 times 0.125 divided by 0.0821 divided by 293 equals 0.005, well, there's 3 sig figs, 0.9, and unit-wise, kelvins cancel, liters cancel, atmospheres cancel, and I'm left with moles as the denominator of my denominator. So that's going to flip up top, and that's going to make this moles. Now to find the density, density equals mass, 0.427 grams, divided by moles, 0.00509 moles. And pushing numbers in my calculator, 0.427 divided by the answer that was still sitting in my calculator. And I get 83.8 grams per mole. And if you check, this could be krypton, because krypton's molar mass is 83.8 grams per mole. So you see, we can find the density, we can find the molar mass is 83.8 grams per mole, so we know it's krypton. Yeah. So we can the density can help us identify what the gas is. So next, if it worked one way, you can work it the other way. If I find the density, then I can use that to find the molar mass We did it when it was at STP. Now what do we do if it's not at STP? Well, I'm going to put together a few equations. So this is just a simple algebra proof, and we're going to end up with a final equation that we can use. So we know density is mass over volume, and that molar mass is mass over moles, which in letters would be m over n. And we just solved the ideal gas law for n. So PV over RT is n. So I'm going to put these three equations together. So first I'm going to substitute that for n into my equation. I do that. That gives me molar mass is m over PV over RT. We don't like fractions in the denominator, so we're going to invert and multiply. So that's going to bring the RT to the top and leave the PV on the bottom. Now I've rearranged P and V for a very specific purpose. By rearranging it, you can see that right here I've got mass over volume. And that means that the molar mass is density times RT over P. That molar mass equals dirt over P. So that means if I know the density, I can find the molar mass. Or if I know the molar mass, I can find the density when you're not at STP. So let's do a couple examples. So find the density of helium at 25 degrees Celsius. Since they want density, they tell you one temperature and one pressure, 6.7 atmospheres. So molar mass equals dRT over P. So I've got to get D by itself, so I multiply both sides by P. And divide both sides by R and T. Sorry about that. It went someplace I didn't know. Let's go back. So I was dividing by R and T. So I end up with D equals P times the molar mass over R and T. So the pressure was 6.7 atmospheres. Times the molar mass. The molar mass of helium off the periodic table is 4.00 grams per mole. R, I want the R with liters in it, so that's 0.0821 liter atmosphere over mole in Kelvin. And the temperature was 25 degrees Celsius, which is 298 K. You push those buttons, 6.7 times 4 divided by 0.0821 divided by 298 equals, well, with two sig figs, because of the 6.7, 1.1. And unit-wise, atmospheres cancel, moles cancel, kelvins cancel. And I'm left with grams over liters, which is really good because I was looking for a density. So, given, I can find the density using the molar mass, rearranging the equation. And I can do it the other way, and that is the last example today. Gas has a density of 2.54 grams per liter, so that's a density. At 25 degrees Celsius, that's a temperature. 0.97 atmospheres, that's a pressure, and they want to know molar mass. The equation has those pieces, molar mass, let me write two M's there. Molar mass equals dRT over P. The density was 2.54 grams per liter. R, I want the R with atmospheres in it again. 0.0821 liter atmosphere over mole Kelvin, times the temperature, which was 298 Kelvin, divided by the pressure, 0.97 atmospheres. So 2.54 times 0.0821 times 298 divided by 0.97 equals, with 2 sig figs because of the 0.97, 64. Atmospheres cancel, liters cancel, Kelvin cancels, and I'm left grams per mole, which is a molar mass. Okay. Now, what we can do with this is, now that we can find the molar mass by measuring the density, we can put that together with the information for empirical formula to figure out the molecular formula. Remember that the empirical formula, to turn it into a molecular formula, you need to know the molar mass. The density of the gas gives us one way to do that. So tonight's homework is on a form on Google Forms. Go ahead and give that a try. And if you have any questions, drop me a line. Take care.